Okay. All right. Real quick here. I want to start right with the problems we left off on yesterday. We have a couple new things to cover today. In fact, I'm going to put kind of outline on the board since we're going to be covering a couple different topics here. We're in the third section. We're talking about functions themselves. In the last couple sections, what we've done is you've learned what a function is. We talked about the parts, how to substitute things in, or talk about like how to go through like the actual different forms of relations, like how you display data, how to graph things roughly, if you had to put a table or whatnot together. But today what we're going to be discussing for the new part today, what I want to cover is we have like three major bullets I want to cover. The first bullet is what we left off on yesterday, which is called a differential quotient. This is like a major part of calculus. This is just a small piece of it, but if you can get the idea of how to do it now, it makes your life so much easier if you have to go to an upper level calc course, because this is I'm not joking, they spend an entire semester on that simple topic, that differential quotient, and what all the uses for it, because it has a ton, believe it or not. So it's one of the major pieces of Calc 1. And you guys just get a little piece of it. And today we're going to get to those more challenging ones, because yes, I gave you kind of an easy one. The one we talked about, what differential quotients are. Their slope. Basically, it's an average slope. Well, today we're going to do it for curves. So how do we apply to a curve going out of Highway 18, that type of thing. But after differential quotient, we need to talk about something new, which is even and odd powers. Even versus odd. And what I'm talking about here is this is a type of symmetry for a graph. This is we're adding little pieces as we go, so that when we get to those later sections, when we have to graph a polynomial, something where we're not going to set up a table and plot random points. We'll still do that in certain cases, but this is a huge piece of it, like looking at a graph and knowing if it's symmetric or not, the symmetry of it. So that's one piece. And then the last thing we're going to finish with today is to review kind of the ideas that we were doing yesterday, where you interpret graphs. So it's graph interpretations. So it's taking a look at a graph, seeing what is the increasing, what's decreasing, where's the constant domain, what's the min and max, are they relatives, are they absolutes, that type of thing. So we're going to kind of review that today. We're going to spend a lot of time on the differential quotient. That's going to be what we spend the most time on today, and that's what I'm going to basically expect to see out of you before we're done today. I'm going to give you a problem, and I want to see it on a piece of paper that you can actually do it by yourself. So you're going to be kind of held accountable today for that one, because it's not easy. It's something you just have to be able to do. Let's go through the formula for it. I'm going to leave the formula up here on the board so you can kind of see it. So whatever your function is, so remember, the function itself has a name when you're going through it. Sometimes they call them f of x, sometimes it's g of x, whatever it is, whatever that terminology is that they're going to use the name of it. You're going to apply this basic formula to a differential quotient. So, differential quotient. And this, like on a test, I always have this formula printed. It's actually printed right above the problem, but it's this. That's what we talked about yesterday. F of x plus h minus f of x, and all divided by h. That's the generic formula we're going to use for these next 2 or 3 problems that I want to cover. What we talked about yesterday is the generic way of doing slope. Slope, an average slope in algebra class, we talked about that yesterday, was this. This is what you learned in Algebra 1. You subtract y values, you subtract x numbers if you had coordinates. Like you take the y numbers, you subtract them, you subtract the x numbers in a certain order, and it gives you the slope. If it's positive, it's going up to the right. If it's negative, it's going down to the right, that type of thing. Well, that's what this is. It's choosing a coordinate that's later down the road, some plus h, so that's h down the road. It's subtracting the original f of x. F of x is, by the way, just represent y's. It's these. And then on the bottom, they're subtracting. So it's a later time. So y2. I should say x2. It's some earlier dot. But on the bottom, they're actually subtracting these in order. They're actually subtracting the x's. Just it happens to be that the 2 x's they're picking was x plus h and an x. So when you're going x plus h and you're subtracting an x, that's why the x's on the bottom cancel and you're left with the h on the bottom. That's the concept. That's what you're doing. So it's an average slope. But it works for anything. This formula can give you slope on any type of formula. It doesn't have to be a straight line. So if you're looking at a curve, so if we're looking at a generic picture of a curve, something like this, let's say that's my function, the slope changes constantly. From when you go from the left side to the right side, the slope is constantly, sometimes it's really steep where it's, like 3/1. It can eventually go to, half, 1/2. Eventually it can reach 0 slope where it's, it's exactly horizontal, that's 0 slope. Then eventually it turns negative. Then it eventually goes back to 0 and then it goes back to positive for slope. And slope is that line. Because any curve, if you zoom in far enough on the curve, it eventually represents a line. Like if you can go so close together, these numbers that you're picking, you can eventually get these individual slope lines. That's why you're seeing all these hash marks on this picture. Well, what this formula does is it gives you the generic formula to find slope at any moment on the curve. And that's what we're going to use it for. But the problem is, what most people struggle with is just taking whatever function I give you and somehow plugging it into this thing, like getting it set up correctly. You would not believe. I did it yesterday just to see kind of where my calc kids are, because they're doing derivatives in Calc 1. That's basically a fancy word for differential quotient. And it was the first day of getting to those major sections in calculus. Well, I gave them a problem. All they had to do was that again. Something that you guys are covering right now. We covered it throughout the year. But it was just doing one of those, and it was consistent. They could not set it up. The setup is the hard part. Getting this plugged in correctly, what it's supposed to look like. But then after they can get it plugged in, then they're fine. They know how to do it from there, because it's very straightforward. But they just couldn't get the setup. It's always what you start with and how to plug it in. And that's the part that I'm trying to stress today. Can you even set it up correctly? So, let's start with kind of an easier one, and then we'll work our way to the more challenging ones. So, let's do this. So y equals, let's go with 5x minus 2. We're going to start with something easy. And we're going to work our way to super difficult problems, and we got to find the differential quotient for it. So, what I'd like you to do right now, write that problem down right now. Let's give me our example for the first one. We're going to start easy, and then we're going to work our way harder and harder and harder and harder. And I'm talking difficult to the point where we're done. Now, do you agree that's a linear equation? It doesn't have powers on the variable, right? It doesn't have like x squared or x cubed. So this is linear, so it does have a slope. It's actually in y equals mx plus b form. So what's the slope of that thing? 5. My answer should prove that it's 5. Because this differential quotient, all it's good for is giving you what the slope is. So we already know the answer is 5 before I start, because I want to start with an easy one to just kind of show you this again. But then we're going to get to more challenging problems where you don't know the slope, because it's actually a curve, so it changes over time. But what the differential quotient will do is it will give you that formula so you can actually find slope for it. So here's how you set it up. You're gonna, so that's my problem. You're gonna set it up where you have a big fraction bar and put h on the bottom. Because again, what I'm doing is I'm representing this thing. This is what we're doing right here. We're doing this thing. So h is on the bottom, agreed? Every time. On the top, we're gonna be subtracting two functions, and these two functions are based on that thing, the thing you were just given. So y is a fancy way of saying f of x. That's y is the same thing. It's just the name of the object. Okay. So we're going to subtract the original function in the back. So that 5x minus 2 is going to go back here, and we have to put it in parentheses. We're subtracting the original function you were given. Does that make sense? Like what's in the back? In the front, this is the part 99% of people get wrong. They just don't set it up correctly. Where whatever your function is, whatever the function is, you're going to substitute in an x plus h into all the x's that you see. Wherever there's an x on your original problem, you're going to plug this into it. And that's the hardest part. So I'm going to put this in brackets. I always put it in brackets, whatever this is, because it could be really complicated looking. So my original function is that thing. So it's this. Okay, that's the original function, 5 times x minus 2. But what are we plugging in?
X plus h.
X plus h. That has to go into any spot where there's x's. So you take out the x's and you plug in an x plus h into it. Now, you're probably thinking, okay, well, that's not that hard. The thing that people get wrong is they always just go, oh, what this is just the function, you just add an h in the back. No. You take out all the variables and you substitute in a new one. This is the new variable we're plugging in. That's how you do substitutions. I mean, you were literally doing that in the last homework, page 143 and 159. You were substituting in numbers and coming up with answers for them. That's what we're doing here. We're substituting in x plus h, not just a number. Okay, questions on the setup. You have it set up now. Now all we have to do is the math and simplify and get my answer. So you've done the hard part. That was the hardest part. It's just getting that formula written down correctly. We'll do it for more difficult ones as we go here, so you can see it. Okay, so in the front, all we do is just simple math. Let's distribute the 5. What do I get when I distribute the 5 here?
5x plus 5h.
Good. 5x plus 5h. Keep going. What else do we have?
Minus 2.
Minus 2. Okay. And now let's keep going. What do we get in the back?
5x plus 2.
Okay. 5x plus 2. Because you have to distribute that negative sign to the back. And that's all over h. You have to distribute the negative sign to the back. That's why I put it in parentheses. So it became a plus 2 in the very, very back. Now, what I warned you yesterday, and this was just a little side hint, that if you know you did this right, you know you plugged in everything, you set it up right, when you get to this stage, right where you have the green part here, and you're going to start to add and subtract like terms. What should happen if you've done this all correctly, anything that does not have an h on the top, so there's a lot of things that don't have h's, 5x's, there's a couple of 5x's, there's 2's, whatever doesn't have an h should go away. They should somehow magically all start subtracting off perfectly. And you're actually seeing it here. It is actually happening. The 5x's actually drop out because one's positive, one's negative. The 2's drop out. So anything that does not have an h on the top will go away. That is guaranteed if you did it right. Then what you're left with, whatever's left, whatever has h's, you're just going to write those down. Well, I only have one. I only have 5 h on the top. Because there could be a couple items if we get to a more difficult problem. And we have the h on the bottom. Well, what do you get when you divide that? 5. And that's your answer, right? So your answer is 5. And this represents the slope of that object. It's slope at any time period. Well, this one just happens to be a number, right? It's a constant. It's a 5. That means since there's no variable there, the slope is always the same number every single time, no matter where you're at in that line. It doesn't matter if you're 20 down the road, if you're negative 15, on the left side of the x-axis, your slope will always be 5 no matter where you're at, because it's linear. It has the same slope the entire line. Does that make sense, like what you're finding? The problem is, like that last drawing that I did where I had that curve where it's going up and down, that slope changes. So if we ever had a problem like that, that slope changes constantly, so what you'll be left with in the very end when you do this will be a formula, because it's not a set slope the entire time, it's not a constant. It'll change. So they'll give you a formula and then you can plug in numbers to figure out what the slope is at any certain moment on that curve. So that's why this formula is actually extremely important. Okay, we're good with the first one. Let's do a second one. Now we're getting a little more difficult. Not super difficult, just a little more difficult. Okay? Alright, so second one. Now we're going to add curves to this thing. Let's go with x squared plus 3x plus 2. This is a curve. It's actually a parabola. It's a quadratic. Eventually, in these later sections, we're going to talk about graphing parabolas. You did that in Algebra 2. But we're going to review that, the processes for graphing. And plus, we're going to talk about how to graph polynomials, random things. I can guarantee you right now, this problem is more difficult than the last one because it's a curve. It actually changes slope. Okay, this thing, if we were to actually graph this, it would hit -2 and -1, and this is what it's basically gonna look like. It's gonna look something like this, and you'll eventually in this class, we'll figure out why do I know it looks like that, how do you know what's all the steps, because there's simple things I look for. So it's gonna look like this generically. Well, that means the slope is actually changing. So, you know, it's really steep, eventually it kind of levels off to 0, then it kind of changes to positive slope, right? Depending on where you look at in the graph. Any certain spot on this graph has a different slope, you know, because it's changing, it's like a curve. So, my generic formula will not be a single number at the very end. It won't be 5, like the last one, because the slope changes as you go around this curve. So it's going to be a generic formula. But the problem is we have to get this thing set up correctly. So we have to use this differential quotient for this problem. So the differential quotient, what has to go on the bottom? H. What do we need to subtract in the back? What's subtracted in the back on the top?
X squared plus 3 plus 2.
Yeah, the exact function. So we have to subtract the original function that they provided you. So we're subtracting the x squared plus 3x plus 2. We're subtracting that. That original function has to be in the back and we're subtracting it off. In the front, we have to have a bracket. We have to have a bracket. Because we're going to write the function down, but now we're plugging in new letters into it. So you have to write whatever your function is in the bracket, and what I always do is I just leave the variables off of it. So it's, you know, some x squared plus some 3 times an x and then a plus 2, right? That's what the generic formula looks like. But we're not using x's anymore. What are we plugging in instead? X plus h. That has to go in all these spots. So if there's multiple x's, they all come off, it all becomes an x plus h. That's the goofy part about doing this. Alright, questions on the setup. How we plugged it in, why it looks that way. Now comes the tricky part. We have to do some serious work now. Because this part right here, you don't distribute the power of 2. That's not how you do that. You have to actually FOIL. This is 2 parentheses side by side, we have to FOIL it together. This part you distribute, it's a single number, so you distribute that single number. Back here you distribute the negative sign, but right here, this first parenthesis now, it's no longer distribution, now it's a FOIL, and we have to figure out what it looks like. Okay, so let me write this down. So what we're doing here, this next line, is we're doing this. X plus h, we're going to be FOILing those together. That's the first thing. I'm going to distribute the 3 to the back here, and I'll distribute the negative sign. So in fact, I'm just going to do that right now. 3x plus 3h plus 2. So that's distribute the 3 plus 2. Now I'm going to distribute the negative sign to the back, so I have a negative x squared, negative 3x, negative 2. And this is all over h. Alright, questions at all about setup so far?
Why didn't you just put like x squared plus h squared?
Because you don't distribute a power 2. That's the only time you distribute a power, like when you put the square through a parenthesis, is if it's a single item on the inside and you have power on it, then you can distribute the power to everything, right? But when there's a plus sign in between, like that, you don't distribute the power. You have to actually you have to go to the definition of what this means. It means that there's 2 of them. 3 plus x. So, because then you have to FOIL. That's how you know. Okay. So questions on the first step. That was a great question now. Any other questions you have while we're doing something? Okay, Madeline just kind of soak it in for right now. Sorry, I'm kind of walking into the deep end now. All right. Let's distribute or FOIL, however you want to say this. What do I get when I FOIL?
X squared plus 2xh
2xh
plus h squared.
plus h squared. Okay, because it's x, xh, xh, h squared. So there's going to be 2 xh's in the middle. You have to go first out and last. You just combine like terms as you did it. That's pretty good. You don't have to combine like terms. You can wait till later to do that. But first, outer, and then inner last, and you got to get all your letters correct. He actually added them, which is really impressive. Then we have all these other things in the back. Minus x squared minus 3x minus 2. My God, it just keeps going. There's an h on the bottom. All right. So far, so good? All right, so now what I warned you of, so we did all the FOILing, first, after, and last, blah, 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 blah. We did all the distributions and the negative signs and all the other terms. What should go away if you did everything correctly? What did I say earlier?
Everything but h terms.
Everything but that does not have an h should go away, guaranteed. That's how you know if you did this right. If you set up the problem from that to here correctly and you distributed correctly. So x squared, yeah, duh, those are gone. One's positive, one's negative, boom. So far so good. 3x, negative 3x, boom. 2, negative 2, boom. And everything that's left has an h on it. That's how you know you're doing it correctly. Anything that has an h is still around. And what we're left with, we did all this work, we've written it down, so what we're left with here is we're left with 2xh plus h squared plus 3h. That's all on the top, and I think that's all the h terms. And we have an h on the bottom. And now we need to divide. So what do you get when you divide everything by h? What's my last answer?
2x plus h plus 3.
2x plus h plus 3. What this represents. This represents your slope at any given time on that thing. So anytime, because this represents a curve, right? I was showing you that picture of what the curve kind of looked like earlier. This is the slope at any moment on the x-axis. So if I were to plug in an x number, and we always assume h is 0 at the very, very end when you're attempting to find the slope, h is going to be 0. It won't affect it. But you plug in any x number you want, and whatever's left, you can add them together, and that's the slope at that exact moment on the curve, which is crazy. So you can actually figure out when the slope would be 0, you can figure out when the slope is half, or a really steep or negative slope, and it will actually, the numbers you plug into x will actually give you that. So it actually directly correlates to the numbers. So like when you go out of 18, or you go north by Quickster on that curve, changes directions a couple times. That civil engineer set the speed limit on that curve, because this is what they did. This is it, I'm not joking. This is the formula they used. They just plotted points on a grid and said, okay, you should go about 20 miles an hour. That's the slope at that range. At that moment in time, the slope should be 20 miles an hour for this weight, blah, blah, blah. They put weight, they put gravity, consideration, tires, all that good stuff. So there's a lot more math to it, but this is the generic thing that's in the background that they had to do first. Questions on the setup? Trust me, it's like, once you do enough of these, it's fine. But you have to get the setup correct. This is the most important part. You have to get this set up on your own, because I'm not giving you that. What I give you on a test and homework is that, and you have the formula off to the side, and you have to do all the rest of the stuff yourself. You have to set it up, simplify it, and get down to this final slope formula, which is the slope that you need. Okay, questions at all? Okay, let's do another one. I'm gonna start to stop the camera here, and let's do another one, but let's go difficult now. Okay. Madeline, hopefully after watching this one, you'll kind of pick up what we're doing here, because I know you kind of walked in right at the worst time there. All right. So, let's do another one. But now let's go difficult. Okay. Okay. Next one. Doesn't look any bigger or badder than the last one. It kind of just looks the same. This is a curve. If we get to those later sections, the next couple sections we'll learn how to graph random polynomials. one of the things we'll talk about is that this is a cubic function. Cubic functions look something like this. It's kind of generically what they look like. So again, you know, the slope at any given moment is changing. It's radically changing. You know, it's going from positive slope to eventually 0, maybe to negative slope for a while, and then back to, you know, positive slope. It's actually changing directions multiple times. So that's kind of a generic look for a cubic function. We'll eventually learn in this class how to figure those out, you know, how to graph them. But, so my final answer isn't going to be just a single number, because as you can tell from that picture, slope changed. So it's not just a constant slope the entire graph. It changes from positive to negative, so we're going to get a generic formula on this one. Can somebody walk me through what's the setup? What do I need to write down? What do we have? How do we set it up in the differential quotient for what I gave you?
Negative 4x minus 2x plus 6 at the end.
Okay, so good. I agree with that. So you're going to be subtracting this, and you already distribute it in your head, which is great. So if you didn't hear, he was saying negative 4x cubed, negative 2x squared, positive 6, distributed. That's fine, that's in the back, good. What else? What needs to go on the bottom? Okay, good. So at least we're getting that right. Now, the all-important front. What goes in the front?
4 parentheses x plus h parentheses to the third
To the third?
plus 2 parentheses x to the h and parentheses minus 6.
Minus 6. Boom. And that's what makes this difficult, is right there. That's the setup that, if you're going to get these right, you've got to get that first line. That line needs to be written correctly. If you want to distribute the negative sign in the back, you're fine. You know, you can do that in your head. But that first bracket needs to be set up correctly. You need to put the x plus h's wherever there's an x on the original problem. So like if there's multiple x's here, because I could have had another one in there, I was missing a term. But you'd have to put x plus h into all of them. Now what makes this difficult? It's because you have a cube in the front, and you have that square in the middle, and you have numbers in front of them even. So it's not really, I don't know if it's difficult, it's long, like really long. It just takes a long time to actually compute this. So, I'm gonna need probably all the board space I can get. Okay, so going through this here, let's write this out. So what this means is I'm doing this. I have 4x plus h times x plus h times x plus h. There's 3 of them, right? I have plus 2, and now I have 2 parentheses, x plus h, x plus h. I have the minus 6, and then like what Andrew was doing earlier, he distributed the negative sign earlier, so you had the negative 4x squared, or 4x cubed, negative 2x squared, positive 6, and this is all over h. Not easy. Okay, now what do I have to do for those parentheses in the front? Foil. Yeah, and that's where, this is where it gets really, really ugly, that we're going to have a lot of stuff, because I have to foil up 2 of these together. I can't distribute the 4 yet. I actually have to foil these together first, and once I have the final answer, then you can distribute the 4 through it, because you have to do the parentheses first. Then back here, same thing, I have to distribute, and then, or I should say foil, and once I hit foil, then I can distribute the 2. And then the back, everything's kind of good back there. But yeah, so like you can start to see like this is difficult. Because these are kind of the same thing that we just did earlier. I'm gonna do the 3 parentheses right here. I'm gonna do the first 2 together. We did that one earlier, that was x squared plus 2xh's plus h squared. That was doing the first 2 together. We still have to distribute another one. Same back here, I have the x squared plus 2xh's plus h squared. Then I have the minus 6 minus 4x cubed minus 2x squared plus 6 all over h. Jeez, it's getting long. It's getting long now. I haven't even finished that FOIL process yet.
Why did that, 2 switch to a negative?
Where? Ooh, thanks. Didn't catch that. Ooh, that would've been really bad. Ooh. That would've been really, really bad. Double check. You got everything else right? Yes. Ooh, yeah, thank you for that. Ooh, that would've been terrible. Okay, so far so good. Okay, next one here. I'm gonna FOIL these together. And then I'll still have the 4 out front. Yikes. So what do we have? So we have 4 parentheses, I'm gonna distribute. So I have x cubed plus x squared h plus 2x squared h plus 2xh squared plus h squared x plus h cubed. So that's distributing this, and I still have the 4 sitting out front. Oh my goodness. That's just distributing those 2 parentheses together. And now I have to write down all the rest of the stuff by distributing the 2. So I have 2x squared plus 4xh plus 2h squared. Oh my goodness, it just keeps going. I'm running out of space. And all I've got so far is I just went through here. I've done all this stuff up to here now. I haven't even written back yet. Yikes, I ran out of space. So we have the minus 6 minus 4x squared. Oh, this looks sloppy. 4x cubed minus 2x squared plus 6 all over each. Ugh, ugly, ugly, ugly. Let me double check before I move to the next step, because I know a lot of you are like scrambling to write this down. X cubed, x squared h, 2x squared h, 2xh squared, h squared x, and h cubed. We have 4 out front. 2x squared, 4xh, 2h squared, negative 6, negative 4x cubed, negative 2x squared, and plus 6. Yes, everything's written correctly so far. It just looks ugly. What's the next step I have to do? Let's do the 4. So it just keeps going. 4x cubed plus 4x squared h, bless you, plus 8x squared h plus 8x h squared what am I at? Plus 4h squared x plus 4h cubed. Oh my goodness. And then, so all I did so far is up to here. Distribute the 4 into that parenthesis. So 4, 4, 8, 8, 4, and 4. Okay, good so far. And then all the rest of the stuff, I'm just going to write this down like this. This is terrible. 2x squared plus 4x h's plus 2h squared minus 6 minus 4x cubed minus 2x squared plus 6 all over h. Exactly. Takes a lot of word space. I only did power 3. I think it's probably in the book that had power 4, I think. Okay, how do you know if you did this right? What's going to happen? Anything without an h is going to go away. It's guaranteed. If it doesn't have an h, it's gone. So you're going to start to see, I'm going to cross these out right now because I want these things to go away. I need this thing to be a lot easier to write down. 4x cubes are gone. 6's are gone. 2x squares are gone. Everything else has h's. Yes, everything else has h's. I can add like terms. There are certain things that do match here. Like for instance, 4x squared h, 8x squared h. Xh squared, xh squared. Those can add together. Then everything else is separate. So combining like terms, it looks like I'm going to have 12 x squared h's. I'm going to have 12 x h squares. I have 4h cubed, a 4xh, and a 2h squared. And this is all over h. Last step. It's the last step.
Dividing.
Dividing everything by h. So we have 12x squared plus 12xh plus 4h squared plus 4x plus 2h. And there you go. There is your slope. That is the final answer that I'm looking for. That is your slope at any given moment. So on a civil engineer would do, all the h's would become zeros. They would plug in the number into your x, whatever part on the curve you're at, and that would be your slope at that exact given moment.
Sure.
Yes.
Are there gonna be problems like that in our homework?
Yes.
Or tests?
Wait,
Yep.
so if, when you're actually finding the slope,
Yes.
if h is 0, does that just like make these terms, like the ones
Go away.
with xh
Yeah.
and 4h squared, they just don't matter?
They don't matter. They don't affect slope. So eventually you start to figure out why, because at those moments, time doesn't apply. So you throw those out. I can kind of estimate when I first look at a problem what the slope is roughly going to be, and that's what you learn in calc, like all these like rules for when I look at that thing. I knew it was going to come down to 12x squared, and there was going to be an 4x, and there was going to be, you know, a bunch of h's behind it. So by looking at the problem, I can see that right away, so I kind of know roughly what it's going to be, but again, that's Calc 1. They teach you little strategies that you can look at. I know this is difficult. Tomorrow, you definitely need your textbook tomorrow. We're going to get homework tomorrow for sure. Today was about getting this done. We didn't even get to talk about even and odd symmetry, which is not very difficult compared to this stuff. This stuff is hard compared to everything else we're going to be doing. This, like, I consider this to be probably the most challenging stuff for a while. It's just because how long it takes, the level of difficulty. There's so much work that you have to write down. And you can't cheat it. Like, you can definitely see if you're putting in the work on those. You can't just go, oh, I did it in my head. That doesn't apply. Can't happen. All right, tomorrow, you ready to go? We'll try to do a one of these tomorrow. So right when you walk in, I'll probably have a ticket for you. Like right when you walk in, I'll give you a problem. I'm going to see if you can do it in front of me. An easy one, not like that. And then we'll go to some of the other things. Okay.
The problem itself is